Solving proportions.
Welcome to Mark's Math Methods.
Proportional means two ratios are equal. Another way to say it is one fraction is equal to another fraction. Here's some examples. 1/2 equals 3/6, 7/9 equals 21/7, 12/15 equals 4/5. Each of these are proportional because the ratio 1/2 does equal 3/6. The ratio 7/9 does equal 21/27. And the ratio 12/15 does equal 4/5. Solving a proportional problem is a straightforward process. Solving means one of the values is missing and needs to be found. So if I took one of the numbers out from the previous ones, 1/2 equals something over 6, 7/9 equals 21 over something, and something over 15 equals 4/5. These would be proportions that need to be solved. Okay? What we do is we put letters in place of the missing piece as a placeholder. There are three main ways to solve a proportional problem. One, think of it as converting a fraction to a new denominator. Two, cross-multiplying up. And three, clearing the fractions, multiplying both fractions by the least common denominator. Think of it as converting a fraction to a new denominator is not always easily done depending on the values and where the unknown is. That's the letter representing that missing value. Cross-multiplying up is the most useful method at this level. And clearing the fractions is the method used routinely in algebra. We're not going to talk about it in this presentation. There is another presentation on clearing fractions. So let's try an example proportion. Find the value of x to make the statement true. If we thought of this as converting 2/3 to a new fraction with a denominator of 6, then we just have to figure out what do we have to multiply times the 3 to make the 6, which is the 2. We put the same thing in the top, and we multiply across to get 4. So 4 would be the value of x. 2/3 equals 4/6, and so 4 would be the value of x. This method works great when the unknown, the x, is in the numerator, and it is easy to convert one denominator into the other. Like this was easy to convert the 3 into a 6. Let's do the same proportion a different way. Let's do this one by cross-multiplying up. So 6 times 2 and 3 times x. We're cross-multiplying up. We're starting from the bottom. And because we're cross-multiplying up, we get to use the same symbol that's between the two fractions becomes between the two results. Now, if we divide both sides by 3, in order to get the x by itself, we end up with x equals 4, which is the same value we got when we did it by as if we were just converting the denominators to at least. Let's look at this one more closely. Here's what we ended up with just before that final step of reducing. X equals 6 times 2 over 3. Notice that the numerator is made up of the numbers that are in the complete diagonal. Notice the diagonal that does not contain our unknown, the 6 times the 2. And that the denominator is the number opposite the unknown, which in this case is the 3. And then we can reduce to get our final answer. Let's apply this quick method for solving some proportions. X equals, it's going to be a fraction. The numerator is made up of the complete diagonal multiplied together, 11 times 5. And the denominator is the number opposite the x, which is 7. Reduce if possible, can't in this case, and we end up with 55 over 7. How about this one? So x is going to be equal to a fraction, where the numerator is the complete diagonal, 4 times 3, and the denominator is the number opposite, which is a 5. No reducing possible, and we end up with 12 over 5. So in this case, x equals a fraction, where the numerator is 5 times 9, the denominator is 3. In this case, we can reduce, and we end up with 15.
I hope the presentation was helpful. Thumbs up, subscribe, comment. And if you have any problem types you'd like me to demonstrate, there's my address.